Okay. So first thing is to know what is the problem which we are going to discuss. So first we should know what is discriminant analysis. So as we know, it's a multivariate technique and it's a classification problem. So discriminant analysis is a classification problem where two or more groups or clusters or populations are known in advance and one or more new observations are classified into one of the predetermined groups based on the measured characteristics, based on the different independent variables under consideration. So in discriminant analysis, the dependent variable is a categorical variable having two or more categories, and the independent variables are metric or we can say that they are non-numeric. They are numeric in nature. They are quantitative variables. So here in discriminant analysis, just like logistic regression, we use dependent variable as the categorical variable and independent variable as the numerical variables. So discriminant analysis is sometimes also known as discriminant factor analysis or canonical discriminant analysis. So what is the purpose behind studying this discriminant analysis? So the main purpose is to classify subjects into one of the two or more groups on the basis of some independent traits or some independent characteristics, or say, we can say independent variables. And the second purpose is to know the relationship between group membership and the variables used to predict the variable, the group membership. So it is very important to identify which variable is having a discriminative power. So it is a very important thing to, select the independent variables on the basis of which we will be able to discriminate among the units, and we will be in situation to decide that the particular unit should be included in which group. So these are some objectives of discriminant analysis. The first objective is to develop the discriminant function, and obviously we can make different discriminant functions. Now the next is to examine whether there is significant difference among the groups which have been formed through the categories of the dependent variable in terms of the predictor variable. So in terms of predictor variable or independent variable, we'll look into the differences, whether there exists a significant difference between different categories of the dependent variable on the basis of the independent variable or not. So this is one of the objectives of the problem in hand. So now the next objective is to determine of which predictor variable contribute to the most of the intergroup differences. So this is very important thing which we have just discussed, that we have to identify, we have to search for the contributions of the independent variable, and we'll see which variable is more influencing the units to be included in different groups. So that is why we will see how much is the intergroup differences through the independent variables. What is the contribution of the independent variable among the units of different groups under consideration. And the next objective is the evaluation of the accuracy of classification. Obviously, which discriminant function will be made, we'll check its accuracy, whether it is correctly classifying or it is somewhere misclassifying the units. So now these are some applications of the discriminant analysis to identify the characteristics on the basis of which one can classify an individual as. So on the basis of the independent variables, we make a discriminant function, that is a discriminant analysis function, and on the basis of the values of that, we decide which unit is to be put in a particular group. So these are the characteristics on the basis of which we will classify the individual as whether it is basketball player or it is volleyball player on the basis of the anthropometric variables, the independent variables, and to identify or classify the high or low performer on the basis of the skills of the player, and to identify whether the person is junior or senior category on the basis of the maturity parameters.
Sir, can you explain what is meant by anthropometric variables?
So many variables. What is the length of leg and what is the length of arm, and these are the
it is height and weight actually. Basically height, weight parameters are called anthropometric measurement.
You can search for that as well.
Okay.
Now there is assumption regarding the sample size. So we know that sample size for all groups should be just like homogeneous type. Otherwise, we will go for the logistic regression. So group sizes of the independent should not be grossly different. That is 80-20. Here, logistic regression may be preferred. If the of units in different groups, making the independent variables in different groups on the basis of the independent variable, if there is a huge difference among the or between the units of the two or more groups, then we will apply the logistic regression. Otherwise, we will, if there is some homogeneity there among the groups, then we will be applying this discriminant analysis. So the group sizes should be homogeneous in nature, and definitely the sample size should be at least 5 times the number of independent variables. So how many independent variables are included in the analysis? So the observations must be 5 times that, the number of independent variables under consideration. Now there is a assumption of normality as well. Each of the independent variables should be normally distributed, as we know, and we consider in different statistical analyses. And there is obviously in different statistical analysis, we consider the homogeneity of the variance and covariances. So all variables have linear relationship. Linear relationship means if we are changing, we are changing a variable, there is a constant impact on another variable. So this is the linear relationship. And outliers, obviously outliers are not good for the analysis. Rather they are bad for the analysis. But if they are important, then we do consider them into the analysis, and we search for some robust procedures. Otherwise, we remove them and then we apply the statistical analysis. So outliers should not be present in the data. Discriminant analysis is highly sensitive to the inclusion of the outliers. So if the outliers are there present in the data, so discriminant function will misclassify the units. So we must check first whether there are outliers in the data, then we should remove them. And after that, we should apply the discriminant analysis. And obviously, mutually exclusiveness should be there among the groups of the dependent variable. So the groups must be mutually exclusive with every subject or case belonging to only one group. There should not be some unit common in any of the groups under consideration. Now classification, each of the allocation for the dependent categories in the initial classification are correctly classified. If we have some misclassified, it means the discriminant function is not of very good efficiency. and there must be variability in the observations of the independent variable. So no independent variable should have a zero variability. It means it should not have the constant observations. So it must have some variations in the data. So there must be some variability in the data of each of the independent variables in either of the groups formed by the dependent variables. So every variable, independent variable in every group must have some variance. Now there are some terminology used for the analysis of this, discriminant analysis. So first is the variables in the analysis are the independent entities. So independent variables are known as here as independent traits or independent entities. And the second one is the discriminant function. This is very important because on the basis of the value of this discriminant function, we classify the unit in two or more groups under consideration. So the discriminant function is a latent variable which is constructed as a linear combination of the independent variables. So how many independent variables you are using, we will be considering the different linear combinations of the independent variables so that we will be able to make different discriminant functions, and on the basis of the values we will classify, and we'll see how up to which extent we are correctly classifying the units in different predetermined groups on the basis of the dependent variable, which is categorical. So the discriminant function is also known as canonical root. This discriminant function is used to classify the subject or cases or units into one of the two or more groups on the basis of the observed values of the independent variables or predictor variables. Now the classification matrix in discriminant analysis, this classification matrix serves as a yardstick in measuring the accuracy of the model, that is discriminant function, in classifying an individual or case or unit into one of the two or more groups. It is also known as the confusion matrix or assignment matrix or prediction matrix. So it tells us as to what percentage of the existing data points are correctly classified by the model or the discriminant function developed in the discriminant analysis. So on the basis of that, we will be able to check which discriminant function is going to be classifying the units more accurately. So in step 4, stepwise method of discriminant analysis may be used. So discriminant function can be developed either by entering all independent variable, or you may enter them step by step. So together or in stepwise, depending upon whether the study is confirmatory or exploratory. If you know, these variables must be added into the category, into the analysis. So if you are confirmed, you are using the confirmatory factor analysis, then you can include all the independent variables at a time. Otherwise, in exploratory analysis, where groups are not made in advance, so we use stepwise regression and we add one by one the independent variable into the analysis. Power of discriminatory variables. This is very important. If discriminatory power is not there in the independent variable, they will not be able to identify or classify the unit in different groups. So after developing the model in the discriminant analysis based on the selected independent variable, it is very important. The independent variable must have impact on the dependent variable. It means it must have some discriminatory power so that we may be able to classify the unit in different category in hand. So that independent variable will be included into the analysis. So it is important to know the relative importance of the variable so selected. how many variables, independent variables are important, and what is the relative importance, what is the special characteristics that it is discriminating the unit from in one group from the another group. And yes, we use the box M test. So the box M test is used to test the null hypothesis that the covariance matrix do not differ between groups. It means the variability or co-variability within the group for all the groups are same. This is considered in the null hypothesis, and we check it through the box M test found by the dependent variable. If the box M test is insignificant, it indicates that the assumption required for discriminant analysis holds true. It means the variability among the units in a group and the units in another group, they are having similar variations. And definitely the seventh one, that is eigenvalues, are very important to check about the discriminant function and the units. So eigenvalue is the index of overall fit. We check on the basis of the eigenvalues whether the discriminant function is a good fit or not. And Wilks lambda, it is sometimes also we call it as the measure of bad fit. Contrary to that, the coefficient of determination, which is considered as the measure of good fit. So it measures the efficiency of the discriminant function in the model. Its value shows how much percentage of variability in independent variables. While in coefficient of determination, whether my voice is clear? Am I audible?
Yes, sir, audible, sir.
Okay. So this is, very important Wilks lambda. So there in that, coefficient of determination tells about the explained variation over total variation. It means how much percentage of variation is explained by the model. But here, Wilks lambda tells how much of the percentage of variation is not explained by the independent variable under consideration. So that is why it is contrary to that, and we sometimes we call it as the measure of bad fit. So on the basis of Wilks lambda, we check the efficiency of the discriminant function. And the ninth one, very important measure, is the canonical correlation. It means it is the multiple correlation between the discriminant function, which is categorical, and the independent variables, which are metric or numerical in nature. The canonical correlation is the multiple correlation between the predictors, that is independent variables, and the discriminant function, which is categorical variable. With only one function, it provides an index of overall model fit, which is interpreted as being the proportion of variation explained. So this is very important. We see how much of the percentage of variation is explained by the model or say discriminant function. So what we do for the analysis of this, discriminant analysis in SPSS. So there are 3-4 steps to be used to carry the analysis in SPSS. In step one, the independent variables which have the discriminatory power are being chosen, and which are not having impact, they are not having discriminatory power, we remove them from the analysis, and we consider only the independent variables which are having some discriminatory power. Now in step two, discriminant function is formed, is developed by using the coefficients of the independent variables, because it is a linear combination of the independent variables. And definitely in step three, we see the efficiency of the discriminant function. So in step three, Wilks lambda is computed for testing the significance of the discriminant function. And in step four, the independent variables which possess importance in discriminating the groups are being found, and finally we predict the classification of the units under consideration on the basis of the final discriminant function. So let us consider an example to carry out this discriminant analysis in SPSS. So suppose the question is to identify a player into different categories during the selection process in a cricket training camp. So here we have some measures which we have just discussed. Different measures on the basis that is independent variables, and on the basis of that independent variables we will classify different players as, say, bowler or batsman. So here the name are height, arm length, leg length, palm length, shoulder strength, and reaction time, and speed, judgment, patience, and then so many observations, so many variables are there to be used for the classification. So next these are the observations on the variables under consideration, since all are metric. So these are numerical observations, and to perform discriminant analysis in SPSS, what we do, we go to analyze and then classify, and then in classify you go to discriminant analysis. There you can see this dialog box will be opened, discriminant analysis, and in discriminant analysis, grouping variable, that is dependent variable. So you have to define the range of the group, because here we predetermine the groups, 1 or 2 or 3. So suppose we are in this example, since we are classifying the player as bowler or batsman only, so 2 groups will be formed here. So minimum is 1 and maximum is 2, and click on continue, and then go to statistics, method, classify. So many options are there in SPSS. We will be discussing one by one. So here see statistics, first option. So you can have the means of the variables under consideration, and you just click on box M, because we wish to know the variability among the 2 groups. And you can have some function coefficients as well, Fisher's coefficient and unstandardized coefficient, or standardized. You can have the values, and click on continue, and then you go to classification, and there you can click on summary table and case-wise result, and there are so many options you can click on. So click on continue, and the output for SPSS will be just like by clicking on OK. Then this is the classification. See, these are the batsmen and these are the bowler, and so these are the parameters or say independent variables. So all are same variables, but on the basis of the values, on the basis of the discriminant function, which is latent variable, we classify which unit or which player is bowler or batsman. So these are the batsmen, and these units are the batsmen, and 20 are bowlers. So you can see here for a batsman, the height is average height is 171, while for the bowler it is 182. And similarly, all the averages for the independent variables are given here with the standard deviations. And these are the number of persons to be classified. And these are the total, all 40 players together, and these are their averages for all independent variable with the standard deviations. Now we go to box M, test. And here we can see, observe that the p-value is very much greater than 0.05, because it is 0.78. So here the null hypothesis is not rejected, and we consider that the variance covariance for all the 2 groups, bowler group and batsman group, are there is similar variation. So the test null hypothesis of the equal population covariance matrix. Now these are the coefficients of the discriminant function. So these are the main variables which are impacting, which are having discriminatory power to discriminate between the bowler and the batsman. That is height, back, explosive power, and judgment and patience. And these are the coefficients. So on the basis of these coefficients, we can form the discriminant function like this. These are the observations which we have discussed. This is the constant which is known as interceptor. And these are the x1 is height, x2 is back, explosive power, x3 is judgment, and x4 is patience. So on the basis of these, we have the linear combination. Since all are negative, so we have minus this, and this is positive, so plus these two values are positive. Yeah, so plus this beta 1 x1 plus beta 2 x2 plus beta 3 x3, and so since these are negative observations, so we'll put here minus sign, and this way you just put the values of x1, x2, x3, x4, and we'll get the value of final value of z, and on the basis of the value of the z value, we will be discriminating that if the value of z is this, then it is a bowler, and it is a batsman. So here is, you can see the eigenvalues for the function 1 means discriminant function 1. We can generate many discriminant functions. So eigenvalues, value is 13.2 overall fit, and the canonical correlation is 0.96, a good correlation, 96% positive. It means there is a high correlation among the between multiple correlation between the discriminant function z and the independent variable x1, x2, x3, x4. And now Wilks lambda is significant. So here Wilks lambda tells about the bad fit. So the null hypothesis is rejected here. That it is bad fit, it means it is a good fit. So you can see here from this canonical code. So this way we can calculate. Now you see the counting, 20% are there. So this is the classification result. No one is misclassified. Everyone is classified correctly. So these are the observations. You can see here. Okay. Now this value, we have just calculated the function at group centroid. So this is the group centroid. It means below this we will it is batsman, and above this it is bowler. So now if you have any query, any question, please ask. We have an example that say of 40 persons, 80 persons, whether they will purchase a bike or not, and the independent variable to be classified as the buyer and non-buyer are the durability of the bike, performance of the bike, and looking of the bike. So you can see here, these are they would purchase and would not purchase. So there are two groups. So now to classify, to apply discriminant analysis, we will go to analyze, then go to classify, and there you click on the discriminant. So here you have to put here the dependent variable, that is categorical, and you have to define say 2 categories. So you can click on continue, and here you select all the independent variable, put them here, and go to statistics. You can check means. You can also go for the ANOVA as well, or box M, and something else if you wish. Otherwise, go to classify. So summary table should be there, and case-wise result. Click on continue. And if you wish to save something, say discriminant scores and predicted group membership, then you can also have them into the data, and just click on OK. So here you can see this is processing summary. Nothing is missing. All active observations are present there. This is the group statistics. You can see the persons are 40 persons are to purchase the bike and 40 would not purchase the bike. And these are the mean score for the independent variables for the purchasers and non-purchasers, and these are the standard deviations. So durability of the bike is 71.1, and it is 30 for the non-purchasers and for 71 for the purchasers. So this way, this is the descriptive statistics. Now we come to box tests for the equality of variance covariance matrix for the two groups, purchaser and non-purchaser. So you can see here, these are the ranks and log determinant. So now we go to test result. Here you can see the p-value is 0.000. It means there is a difference among the groups. So the variability among two groups are not same. And as you can see here, it is 71 average 30, it is 66, it is 44, it is 39, it is 38. So only looking is homogeneous type or similar to each other, so it may not be important to be considered into the analysis. But these two are two variables are having high discriminatory power, because average is 71, average is 30, huge difference 66 and 44. So this way you can check here, it is going to be significant, and as per the data, the result of box M is also that the test is significant. It means variability in one group is not same as the variability in the another group. Now we come to summary of the canonical discriminant function. So you can see here the discriminant function is this. This is the eigenvalue, and the canonical correlation is 0.839. It means almost 84% of the correlation. So the true classification may be up to 84%. So here, this is the first discriminant function. We can form another discriminant function. Now we come to Wilks lambda, which is the measure of bad fit. So here you can see there that it is a good fit, and as the correlation is showing, because it is significant here. So the null hypothesis that it is bad fit is rejected. So now come to the discriminant function. So these are the observations. You can see standard canonical discriminant function coefficients. These are the coefficients for all three independent variables under consider, and this is the structure matrix. And these are this is standardized, and the actual unstandardized are say structural on the basis of the direct observations of the independent variables. So you can see here. You can see here the value is coefficients are 0.84, 0.45, and 0.014. So now we come to the centroid, that is which considers the value of the discriminant function on the basis of the average values of the independent variables. Say here these observations. So it gives the point on the basis of which we discriminate where to put the unit in which group. So purchaser, if they are having almost value of Z almost equal or near to this, around this 1.5 and around to negative 1.5, it will be put into the category of non-purchasers. So you can see here. Now this is the summary. These are the probabilities, 50-50% chances, 40-40% are there. And this is the case-wise study we can see here, which is going to where, and the star and double star are showing the misclassification, as we have shown that only 84% of the canonical correlation is there. So you can see here that these are double star are the misclassified. It means if we rotate and we make some other discriminant function, then it may have good classification. So see here, this is the classification result. Purchasers are 40, but 33 are correctly classified, and 7. Okay, So these are the purchaser 40, so 33 out of 40, 33 will purchase and 7 will not purchase, and there are 40. So it means here 1 and 7 observations are misclassified. So 90% of the original group cases correctly classified, 10% are not correctly classified. So this way we can perform the discriminant analysis in SPSS. See here, these observations are saved here. Now, now let us consider another case of 3 groups. So here we are just classifying the say we have classified the person in 3 categories, purchasing a large quantity, medium quantity, and low quantity. So here you can see we have taken into consideration the 3 independent variables, that is income and perception and the age. So perception has been taken into the 100-point scale. Data has been taken into the 100-point scale. So, okay, this is income and age. So you can classify by the same fashion. You can go to classify, then discriminant, and you have to define here, and you have to define range here 1 and 3. Okay, and you have to select all of those things here, and you go to that one. So mean, box M, and classify as summary table, case wise, and then leave that. So this way you can see. This is the summary statistics, and this is the result. It is having a equal variability. See here, the p-value is more than 0.05. And so this way you can see here that here we have the eigenvalues for the 2 discriminant functions are made here, 1 and 2. And so you can see the correlation. It is having weak correlation and it is having good high correlation 0.91. And which lambda you can see for the 2, it is going to be significant and it is non-significant. So the second function is not working good. And you can see here, these are the 2 functions and these are the coefficients for the 2 canonical function, this discriminant function. And the basis of this, you can go for the centroid, and on the basis of that value, where is centroid observations, we can calculate the, these are centroid. On the basis of these, we can classify the observations. On the basis of the function, one is performing good, second one is not performing good. So on the basis of, if the values of the Z are, close to 2.8, they will be put in first category, large purchaser and medium purchaser. If the values are around minus 0.2 and if minus 2.5, then and this is the cases where you can see here some of the, since 91% correlation was there, so you can see here some of the cases are misclassified. Yes. So this way you can see here 10 all large quantity persons are correctly classified, 2 misclassified, and 1 is misclassified here. So this way you can see here 90% of the original observations are correctly classified, only 10% are misclassified. So this was all about today's discussion.